gonna do any other way because like I feel like I'm gonna get confused and use the wrong and try to use a formula that doesn't work unless I use quadratic formula.
Maybe with the, I don't know what's going on.
Alright, so this all
Needs to go back to 26.
on quadratics here. This one says f of x equals x squared minus 8 is all subtract again to that it's all subtract the same
Whoa.
16 is 45.
My goodness.
Whoa, like my voice in overload. That was craziness. Alright, here we go.
Wow.
So they could try to do 3 different quadratics at the same time. Ha! Yep,
Is that what you hear in your head all day?
that's scary stuff. Isn't it? Scared me for a minute. Alright, so this says y is less than negative x squared minus 2x minus 1. Okay, the only difference in what we're looking at today, we've done equal signs. That's an equation. An equation's got an equal sign. These today are inequalities because they're going to have an inequality sign, which could be that's a less than, could be less than equal to, could be greater than or greater than equal to. So that just means that the actual answer is going to be bigger than a parabola because it's going to be an area. All right. First way we're going to look at this is by graphing. Get me a piece of grapho paper ready. Smartboard's going to be stupid all day today. It's great news. Yeah, I hear you.
At least it's just
Alright, so if I'm going to graph this thing, I'm not going to worry about the less than sign right now. I'm just going to graph it like normal. I know that's in standard form, so I'm going to do my negative b over 2a to start finding the vertex. So it's going to give me x equals negative. My b is negative 2, and my a is negative 1. Okay, so I've got negative 2 divided by negative 2, which is 1, and then I make that, negative.
Well, I thought if it was a positive, you would just, if it was a negative, you'd leave it as a positive. If it's negative b.
When I'm plugging into the quadratic formula, yes.
Oh.
But here I'm just using this formula, negative, and then my b over 2a.
Wait, why would the x be negative? You're dividing negative.
Negative by negative is a positive, yes, but then I got that negative out in front.
Oh.
Okay, so now I'm going to plug that back in for the x's to get my y's. So be careful with this negative x squared here. That would be negative 1 squared minus 2 times negative 1 minus 1. So negative 1 squared is 1, but then I make that negative. Negative 2 times negative 1 is a positive 2, and then minus 1. So negative 1 plus 2 is 1, and then 1 minus 1, 0. So we got a vertex at negative 1, 0. You'll be on the top tier when you get this test grade back too. Want to go left 1 and up 0. So there's our vertex. Now I know this thing is going to open down because of that sign right there, right? My A is negative, it opens down. So if I've got my axis of symmetry in there, I'm going to plug a 0 in, and I know it'll be down here somewhere to get me another point. So I'm plugging a 0 in for the x. Now the good thing about that is, when it's in standard form, and you plug a 0 in for the x, it takes everything out but your c. Because 0 squared 0, 2 times 0 is 0, so all I've got left is a c, which is negative 1. So I'm going to go over 0 and down 1. Okay? Remembering that from a couple weeks ago? That's 1 away from the axis of symmetry, so I go 1 away on the other side. Now here's new stuff. Don't connect those yet. Normally you just draw your parabola and connect those, but this is where the new stuff starts. Since that sign, my inequality sign, is less than, this parabola is going to be a dashed parabola. Okay? If I am, let me make you a colored note over here. If I am less than or greater than, it's going to be dashed. But if it's got the equal line underneath it, it'll be solid. Okay? And you've done graphing like that before where we did a solid line or a dashed line. It's the same on a parabola. So this thing doesn't have the equal line underneath it. So when we connect that parabola, it's just going to be dashed. Okay, so dash, 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 dash. Dash, 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 dash. Alright, so there's what our parabola looks like. Now, we got one more thing to do. Remember when we did these with lines? There was shading involved, wasn't there? Y'all remember that? Was that this class where we did shading or Algebra 3? Must have been Algebra 3. Okay, we'll have to figure out if, because this parabola is not your answer. That's what a lot of people don't understand with the greater than and less than signs. Our answer is everything that's less than this parabola. So is it going to be all around here, or is it going to be all in here? That's what we got to figure out. Okay, and I do that because sometimes people will say, well, less than's got to be lower, and they try to figure it out that way. Well, I would also be lower if I'm over here. So my less than over here lower, or in here lower. So what I always do is pick a test point to check and make sure. And I'm going to pick a test point that is inside the parabola. So that point right there. What's the name of that point that I just plotted on there? That is -1, 1, 2. -1, -2.
What's all that stuff? Is it messing up?
Yeah.
Or you say how you just look up?
I pick a test point that's inside the parabola. So
So
you could
you-
have picked one anywhere in there you
So
wanted
it
to.
could have been like -1, -3?
Yep. Pick one anywhere in there. Okay, so I picked that one, -1, -2, that's an x and a y. I'm going to plug that in for my x's and y's and see if it's part of the solution. It'll be part of the solution if it makes this inequality true. Okay, so my y is -2, so I'll go up here to the top of it, maybe. -2 is less than negative, my y is, x is -1. -2 times -1 minus 1. Alright, so up here on the top, we've got -1 squared is 1, -1. Trying to make stuff so y'all can see it. Then I got -2 times -1, and then I got -1 again. -1 plus 2 is 1, and 1 minus 1 is 0. So that ends up saying, on the left side of the inequality is -2. -2 is less than 0, because we got a 0 when we work the right side out. Is this true? Is -2 less than 0? Yes, that's true. If it had been -2 is less than -3, no, that would have been true, right? But that is true. -2 is less than 0, which means that point is part of my solution. So that means that since that's true, that's the part that gets shaded. So we're going to just shade everything on the inside of our parabola. This is where I get to scribble. Such a good scribbler.
So what if it was false? Like,
Then we would have shaded out, we would have not shaded that point, so we would have shaded outside it. So if it's true, you shade where the point is. If it's false, you shade where the point's not, which would have been outside.
So if it was 1 less than 2, you would shade whatever that is, but if it was 1 is greater than 2, you would shade outside.
Uh-huh.
so you just pick the point that's inside it?
Yep. Yep. Now, when the scribbling really gets fun on these is when you've got two parabolas and you got to find where the shadings of the two overlap. I know, let's do one. Alright, let's look here at y is less than -x squared plus 3. There's number 1. And number 2, y is greater than or equal to x squared plus 2x minus 3. Okay, so this is a system because there's more than one. And we're going to do this by graphing and look at where their shadings would overlap. Don't worry, I'm going to do algebraically here in a little bit. Alright, so that first one, Let's make it be red.
There's a 2x minus 3.
Oh,
Yes. Alright, so on that first one, x equals negative b over 2 times a. Notice that first one doesn't have a b, right? So that's easy. 0 divided by anything is 0, so x is 0. And plug that back in here. 0 squared is 0 plus 3 is 3, so it's going to have a vertex at 0, 3. Now look at its a. Is it going to open up or down?
Down.
Down, because it's negative a squared, right? A is negative 1, so it's going to open down. I can't plug my favorite 0 in because that's where that point is. So I can plug a 1 in, or I can plug a negative 1 in. How about 1? Is that alright? So I'm plugging a 1 into this first inequality here. So it'll be negative because it's got a negative. 1 squared plus 3. 1 squared is 1. Then you make that negative and then plus 3. That gets me a 2. So I'll go over 1 and up 2. Okay, that's 1 away from the axis of symmetry, so I'll go 1 away on the other side. Alright, does that parabola get connected with a solid arc or a dashed? Dashed, good. Okay, now I got to figure out what part of that parabola gets shaded. So you can pick any point inside it you want to. 0, 0 would be a fine one to use. And we're still on this first one, so don't plug it in the wrong one. 0 is less than negative 0 squared plus 3. So that means 0 is less than 3. Yep, 0 is less than 3. So inside there gets shaded. If it had been wrong, I would have shaded outside. Beautiful.
Can you pause just for a minute?
Uh-huh. You bet your boots I can.
What number?
I did positive 1. But negative 1 would also get you 2.
So if you have the shade on the outside, where exactly on the outside do you shade? Like everywhere? Or?
Well, it would technically be everywhere, but I would probably just scribble around
So
it
just as
some.
long as you knew
Yeah.
you were doing that. Okay.
So you're doing the x equation?
Yes, inequality, yes.
What test point did you use?
I use 0, 0. Alright, I'm going to do the second inequality there in blue. I think that's blue. Alright, so we're on the second one now. We're on this one here. So that's going to be x equals negative b over 2 times a. My a is 1, so that's just this negative 1. Now I got to plug negative 1 back in and solve for y. So it's negative 1 squared plus 2 times negative 1 minus 3. 1 minus 2 is negative 1, and negative 1 minus 3 is negative 4. So its vertex would be negative 1, negative 4.
So what number is it?
My x was negative 1. Plugged it in. Got that from the negative b over 2a. Alright, so down there's the vertex. Down on my bottom there, see the big blue dot? Alright, is this blue one going to open up or down? Do what, Kylie?
I'm not here.
It's going to open up because your a is positive. So I just need to pick a point on the other side of it. Okay, if I can get this smart board to work. If I plug a 0 in, 0, 0, I'm left with negative 3, right? So I'm going to go over 0 and down 1. It's hard with all that red. 2, 3. And then that's 1 away from the axis of symmetry, so I go 1 away on the other side. Now will that blue be a solid or a dashed parabola?
Solid.
Solid, because it's got the equal bar underneath it. Okay. Now I got to figure out, does that blue one get shaded inside or outside?
Could you use the same point?
Yep, luckily 0, 0 is inside the blue one. So I'm going to test it again. Gives me 0 is greater than or equal to negative 3. Is 0 bigger than a negative? Yep, so the blue one gets shaded inside. Now your answer for this beautiful stuff that we need to call Miss Cook and let her come look at, your answer is the part where your shadings overlap. So everywhere where I scribbled, I'm trying to get a highlighter and it's not cooperating. Yeah.
What in the world? Why isn't it working?
I don't know. Everywhere where I still didn't grab it, where I scribbled red and blue, should be there, right? Thanks, David.
So if we had like a work to do something with this, we just circle right there. And
Mhm.
I can't even tell. How? Is there another way to do this? Like to figure it out?
We're going to look at doing them with algebraically without graphing. Yeah. See if I can tell right here. It's hard to tell. That looks like, whoops, my marker's not even right where I'm. Like, that'd be like negative 2 maybe. Maybe from negative 2 to 1. Maybe the area where both of the shadings overlap, maybe.
See,
It's
like,
hard
okay,
to tell
so
right there.
I opened mine up too much, I guess, because mine goes from like negative 2 to 2. What if like on the test it's like we just open it up? Like, when you see what I'm saying, like it's mine's wider than yours.
I'm not real sure it is. And I don't know for sure that it is, but you can always just plug points in again to check and see what the y values would be. See where it is. Alright, I'm going to show you how to do algebraically now.
Oh yeah. Is it hard?
No, just like solving a normal one.
Graphing's always harder. I hate graphing. I just don't like graphing because like it's not exact. Yeah.
Alright, so we've got 3x squared minus x minus 5 is greater than or equal to 0.
Can we just do the quadratic formula?
Yep. Our options are, this is a quadratic. It's just got a greater than or less than sign instead of an equal sign. So your options are all the same. Factoring, quadratic formula, completing the square, all of those methods. Since it's got a 3, I know I'm not completing the square. I don't think it'll factor either, because a times c would be negative 15. There aren't any factors of negative 15 that add to negative 1, so it would just be quadratic formula here. So we're going to work it just like normal, pretending that that's an equal sign and do the quadratic formula. Our a would be 3, our b would be negative 1, and our c would be negative 5. This thing's going to make me angry before the day's out. So we got x, I just wrote an x and nothing showed up. There, hey. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So that'd be 1261 plus 60, be 61. So x would equal 1 plus or minus the square root of 61 over 6. Alright. So, what's the square root of 61? It's not a perfect square, is it? There's not even a perfect square that goes into 61, so you can't even break that down any at all. Well, kind of. Kind of. No, it's y'all are making it be harder than you need to. When we did the shading, and I need you to keep in mind, remember that these when it was an equal sign, what we were solving for, those were zeros or roots or intercepts. That was all where it crossed the x-axis. So, see, this would open up. Just some generic parabola there opening it up. If those are the zeros, right? this has got to be everything we would, in the shading, you would shade in there. So that means x is not equal to those 2 points. X has to be between those 2 points. So x can't be equal to 1 plus or minus the square root of 61 over 6. X has to be in between those 2 points. See, the minus is smaller, so it's going to go on the left, and the plus is bigger, so it'll go on the right. So this is your answer. Now, why did I use a greater than or equal to sign? It's the sign they gave me, right? If they'd have gave me just a greater than, I'd have just used it. If they'd have gave me a less than, I'd have used it. Just use whatever sign they give you on that.
Are we doing graph?
That'd be hard to find where the
So
square
you
root of
just
61
use
is.
You just use the same sign?
Yes.
Oh. What?
And the minus, subtract is smaller, so it goes on the left. Smaller stuff goes on the left. The plus is bigger, adding's bigger, it goes on the right.
Alright, so how'd you know that x is between those?
I knew what I was finding. Normally, if it's an equal to problem, you're finding where it crosses the x-axis. But this, I would have shaded in between there, so I was finding everything in between it. So x is everything that's in between them. So that's how the answers are going to look on all of these. You'll just use whatever sign they gave you, and x will be in between your zeros. It's not exactly your zeros because it didn't say equals. Alright, let's look at another one of those. This one's easier. I got x squared minus 3x minus 4 is less than 0. Alright, you can use quadratic formula on this one. I'm not going to. This one I can actually factor. So I'm going to do this one by factoring. A times c is negative 4. What are the factors of negative 4 that add to negative 3? Very good. So that would factor like that. Okay. Now I'm going to set, I know it's a less than sign over there, but I'm just going to solve it like it's an equal sign, so don't worry about that right now. If x minus 4 equals 0, that means x would be 4. And if x plus 1 equals 0, that means x would be negative 1. Now if you use the quadratic formula, those should be the answers that you get down to and end up getting. Okay, so we're looking at x as being between negative 1 and 4, which we wrote that would be negative 1. I used the sign. Now let me show you another way to know, because some of y'all were questioning that. So let me show you another way to know for sure. If we look at this on a number line, if I've got negative 1 and 4, what I'm going to do here is I'm going to test some parts of that number line. So I want to test a point that's to the left of negative 1. Okay, so let's test negative 2. Should negative 2 be shaded or not? We'll plug it in up here and see. Negative 2 squared is 4. Minus 3 times negative 2 is plus 6. Minus 4. 4 plus 6 is 10. 10 minus 4 is 6. Is 6 less than 0? No. So I'm not going to shade that part. Okay, pick a number that's between negative 1 and 4. I could have done 3. I went to 0 though. That gets me 0, 0 is, and negative 4. Is negative 4 less than 0? Yes, so that part, I'm in between those two, which is what we wrote up here. X is between negative 1 and 4. A lot of people see that notation and they get confused on that, but look, it's common sense. The X is in the middle of those numbers. So, X is between those two.
Will we ever have questions like, will we ever have to say where to shade it if we're not graphing?
I don't know. I'm not for sure off the top of my head. We'll check on that.
Can you use that number line check?
Uh-huh. Yep. Yep. you do that? Alright, let me let you try one. You've got, whoops, I don't need this shape picked up in right in circles before. You've got x squared plus 10x plus 9 is less than 0. See if you can get that one solved.
Is the smallest number always going on the left?
Yes. Alright, if I were the one doing this one on my own, I would do factoring. There are factors of 9 that add to 10, 9 and 1. So I would do that. But I want to do it how you did it this time. So, okay, good. I'll stick with Kylie then and we'll keep factoring. X plus 9 and x plus 1 would be our factors on that. If it wouldn't have factored, you're good at the quadratic formula now, so you could have just done that. That gets you negative 9 and negative 1.
This takes so much less time.
Negative 9 is smaller, so it would be the one on the left. How'd you do? Nothing to it. Way faster than graphing on those as well. Alright, tomorrow's stuff, we're going to look at a study guide, work on that tomorrow, and then we'll go from there and get ready for a test on Thursday. Is that alright?
Is this all of our notes?
Your A is 1, so 2 times A would be 2 on the bottom. Okay. You just messed up the 3 on accident.
bottom.
How'd you do that?